Hello everyone. In this video, we're going to determine the inverse of a square root function by adding a restriction, and this is the third part. Let's take this example right here. Determine the inverse of the function f of x is equal to square root of x plus 2 minus 4. So what are we going to do is we sketch the graph of this function. Okay, just by looking at this equation that we have here, we can tell that the vertex is at negative 2, 4. Because remember, we switch and keep. So I'm going to write it down here. Okay, now we are going to determine the equation that we can use to complete the table. Okay, again, the trick so that we can determine the equation that we're going to use is to cover both the h and the k, and whatever's the left over, that is the equation that we're going to use. And that would be y is equal to the square root of x. So from the vertex, okay, so I'm going to plug this 1 and 2 into the x here, and I will show the work on the side. Okay, so the value for square root of 1 is 1, and then the value for square root of 2 is approximately 1.4. Both are positive, so they're going up. So I'm going to write up right there. So then we can go ahead and sketch the graph. We start from the vertex, which is negative 2, negative 4. So I go negative 2, go down to negative 4. So it's going to sit right here. And then from the vertex, we go 1 right. So 1 right and 1 up. And then after that, we go 2 right and 1.4 up. So it's going to sit here. So then we go ahead and say that we can sketch the graph of this function like this. So that's the approximate graph. Now we are going to determine the domain and the range for this graph. So first we have the domain for this would be x is greater than or equal to negative 2. That means starting from negative 2 on the x-axis all the way to the right side. So that is x greater than or equal to negative 2. For the range here, that would start from negative 4 going up. So that would be y is greater than or equal to negative 4. And so we can change the color for this. Okay, now we are ready to determine the inverse for this function that we have right here. There are steps that we need to follow in order that we can determine the inverse of a function. So the first step is to replace f of x with y. So we have the f of x here. We're going to replace that with y. So that is y is equal to the square root of x plus 2 minus 4. So then we go ahead and move on to the second step. The second step is to replace every y with x and every x with y and solve for y. So this y becomes an x and this x becomes the y plus 2 minus 4. So then we wanted to solve for y by itself. So we're adding 4 from both sides plus 4. So then we are left with, that's going to be x plus 4 is equal to the square root of y plus 2. Again, we want to solve for y by itself. So we are going to square both sides to undo the square root and square the other side as well. So that we are left with, that's going to be x plus 4 squared is equal to y plus 2. So then again, we want the y by itself. So we subtract 2 from both sides, minus 2. So we can cross the 2 out. We are left with quantity x plus 4 squared minus 2 is equal to y. So that we will move on to the third step. The third step is to replace the y of the equation that we solved from step 2 with f negative 1 of x. So this y becomes f negative 1 of x is equal to, that's gonna be x plus 4 squared minus 2. And so we are going to sketch the graph of this function. So I'm going to show the work on this paper right here. Okay, just by looking at this equation that we have here, we can tell that the vertex of this function that we have is on -4, -2. Because again, remember, we are going to switch and keep. So then we can go ahead and write the vertex right here. And so we are now ready to determine the equation to use to complete the table. Okay, again, we remember that the trick in determining the equation to complete the table is to cover the h, and we also cover the k, and whatever the rest of the equation that is left over, that would be the equation that we're going to use to complete the table. So that would be y is equal to x squared. So then from the vertex, so we are going to plug this 1 and 2 into the x right here, and I will show the work on the side. So 1 squared would be 1, 2 squared would be 4. Since both of them are positive, then they're going to be labeled up. Okay, so we are going to sketch the graph. So the vertex is -4, -2. So that's -4 right here and down -2. So this is our vertex. And then from the vertex, we go 1 right, 1 up. So 1 right, 1 up. And then after that, we go 2 right, 4 up. 1, 2, 1, 2, 3, 4. So this is where the next dot is going to sit. Since this is a quadratic equation, we are going to use we're going to reflect these 2 dots across. So it's going to look like this to create the parabola. So we have this graph. So this is the shape of this graph that we got for the inverse. Now, looking at this, we can tell that this inverse has 2 branches. We don't have the other branch on the original function right here, which means that we need to restrict this inverse that we have here. Looking at this, we can tell that the right branch of the parabola matches up to this. So that means that we only consider the right branch, because if we cover this, they're gonna match up. If we reflect it across the line of symmetry, y is equal to x. So we are going to erase this other branch right here. Okay, so then we can go ahead and say that the domain for this remaining branch is x is greater than equal to -4. And then the range for this would be y is greater than or equal to -2. So then we go ahead and change the color for this. So again, we actually restricted the inverse. The restriction for this is x is greater than or equal to -4. Because if we don't restrict it, they're not going to match up. If we fold it across the line of symmetry, y is equal to x. So let's draw the line of symmetry here. Let's see if both graphs would match up if they are folded across that line of symmetry. As you can see here, these 2 graphs, when we fold it across the line of symmetry, they're going to match up. So in the final equation that we have here for the inverse, we are supposed to restrict this. And the restriction here is that we only consider the other branch that is to the right of the vertex, and that's actually x is greater than or equal to, that value is -4. So this restriction is very important, because if we don't restrict it, these 2 graphs will not match up. If we fold it across the line of symmetry, y is equal to x. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!